Okay, so welcome back, and now what we're going to do is we're going to start working with Taylor series in different situations, so in different applications and things that we come up with. So the first thing we're going to do is we're going to talk about a special series that comes up called the Binomial Series. And so we're going to develop and we're going to find what the Maclaurin series is, what this binomial series is, because the Maclaurin series for this function is called the binomial series. Okay, so if we take values of r, okay, so first what we're going to do is we're going to consider just positive or non-negative integers of r. Okay, so let's assume for the time being, we're just going to assume, well, consider non-negative integer values of r. So, for example, if we look at f of x equal to 1 plus x to the 0, if r is 0, then that's just equal to 1. Actually, let me move this over, give me more room. Okay, and then if we do f of x equal to 1 plus x to the first power, well, that's just going to be 1 plus x. And then if we keep going with different values of r, okay, so what's this going to give us? That's going to give us 1 plus, 1 plus 2x plus x squared, right? And then the next one, what if we go up one more? R equal to 3. Well, now this is going to become 1 plus 3x squared plus x cubed. And if we go up to 4, okay, this is going to become 1 plus 4x plus 6x squared plus 4x cubed plus x to the 4th, right? And then if we go on, then it'll be 1 plus 5x plus 10x squared plus 10x cubed plus 5x to the 4th plus x to the 5th, right? Because now there's a pattern. And if some of you may notice this pattern of the coefficients, we have 1, then we have 1, 1, then we have 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. So some of you might recognize this pattern from maybe your days, many semesters before, or maybe sometimes years. Back in algebra, when we had these called binomial expansions, right? For example, if we have x plus y to the 3rd, right? Well, this becomes x plus, x to the 3rd plus x squared y. Hold on, let's do this. X to the 3rd plus x squared y plus xy squared plus y cubed, right? And then the coefficients become 1, 2, 2, 1. Oops, 3, 3, 1. Wrong line. So that matches with this one. Notice cubed, the coefficients match. Okay? So that goes back to algebra. Okay, now, why am I bringing this up? Because these coefficients, if we keep going, we're going to notice that these coefficients are going to become what we call binomial coefficients, and this is called a binomial expansion. Okay? Okay, so now again, the expressions that I showed you on the right side are known as binomial expansions, and the coefficients are known as binomial coefficients. Okay, so now what we're going to find out is, and again, if you've taken a class in statistics and where you study probability, usually in elementary or beginning statistics class, there's a section or a chapter on probability, and one of those things that you talk about in probability are combinations, right? And one of the things we talk about in combinations is that the combinations are actually binomial coefficients. Okay, so again, so in general, this is for non-negative integers of r, what we get is we can get the coefficients are given by this formula. So it'd be n choose r, right? N choose r equals what? It's going to be n factorial divided by n minus r quantity factorial times r factorial. Okay, and this is the formula that gives us the binomial coefficients. Okay, now, so what we can do then is this. Okay, I'm going to write it down here. I don't want to erase this, but now using this, because again, this is for non-negative integers of r. So what we find is that if we take f of x equal to 1 plus x to the r, well, this is going to equal n choose 0, x to the 0, plus n choose 1. So again, these symbols is combinations, right? And it just means this formula. So n choose 0, n choose 1, x to the 1, plus n choose 2, x to the 2, all the way to n choose n minus 1, oh, you know what? Oh, no, you know what? I made a mistake here. The reason I wrote this from, this is typically the way we write this. So this is correct. This formula is correct, but again, in the context of what we're doing, I miswrote it, and just because this is how I normally remember it, so I apologize. So again, in the context, r is the takes the place of n. So this is actually r choose n. I had this backwards, okay? Where r is the maximum number of, is the power here, and then n is what's cycling through 0 to n, like we normally use, okay? So I'm going to change this a little bit so that hopefully it makes more sense. So this should be r factorial over r minus n factorial times n factorial. Okay, so that's what it is. Okay, I just had the n and the r mixed up because that's typically the way I write it, okay? And so now this should be R. Okay, not N. Because that's, again, where we're going. That's the degree. Okay, so R choose 0, so this expansion using this formula for the binomial coefficients is R choose 0, x to the 0, plus R choose 1, x to the 1, plus R choose 2, x to the 2, all the way to R choose R minus 1, x to the R minus 1 power, and then plus R choose R, x to the R. Okay, and that is the expansion, and of course we can write this using sigma notation, and this is just the summation from n equals 0 to R, right? R choose n, x to the n. Okay. Now, okay, so far so good. So now let's just give an example. So if we want, now that we know this, right, f is equal to this, right? So f of x is equal to this, and so f of x is equal to this, which is now equal to this. Okay, now we're not done. This is not the Maclaurin series yet, but we're getting there. We're just starting with non-negative integers of R first to get an idea of what this thing looks like, and then we're going to expand this to all real numbers R, okay? So let's take this, and now let's look at using this to say, okay, well, what would the fifth power be, right? So let's say R is equal to 5, right? So if R is equal to 5, then f of x, which equals 1 plus x to the fifth, which now is equal to n equals 0 to 5 of, well, this is going to be 5 choose n x to the n. Well, what is this going to equal? Well, this is going to equal 5 choose 0 x to the 0 plus 5 choose 1 x to the 1 plus 5 choose 2 x squared plus 5 choose 3 x cubed plus 5 choose 4 x to the 4th plus 5 choose 5 x to the 5th. Well, what is this going to equal? Well, now we're going to use our formula, right? So this is going to be 5 factorial over what? 5 minus 0 factorial, which is still 5 factorial, times 0 factorial times x to the 0 plus, well, now this is going to be 5 factorial over 4 factorial times 1 factorial x times x. And then this is going to be 5 factorial divided by 3 factorial over 2 factorial, so times 2 factorial, r squared, excuse me, x squared. And then this is going to be 5 factorial divided by 2 factorial times 3 factorial. Interesting. X cubed. And this is going to be 5 factorial over what? 1 factorial times 3 factorial, or excuse me, 4 factorial. x to the fourth plus finally 5 factorial over 0 factorial times 5 factorial x to the fifth. Okay, so now notice this is pretty much the same as this, except the two factors at the bottom are switched, right? So what does this become? Well, this is defined, 0 factorial is defined as 1, right? So 0 factorial is equal to 1. 5 factorial divided by 5 factorial is just 1. So this whole thing just becomes 1. This is 1, so we just get 1. And then what is this? 1 factorial is just 1, so this is really 5 factorial divided by 4 factorial. And so this actually just becomes 5x. This here, this is 2 factorial, which is 2. 3 factorial is 6. 5 factorial, well actually what we could do is 5 factorial is the same as 5 times 4 times 3 factorial, right? And so this 3 factorial cancels with this 3 factorial. And then this 2 factorial is just 2. So 2 divided by 4 is 2. And so we get 10 x squared. Well, by the way, well, this is the same as this. So we get plus 10x cubed. And then this is the same as this. So we get 5x to the fourth. And then finally, x to the fifth. And we get our binomial expansion. Okay? With the corresponding coefficients. Okay, now. Okay, I know it took a little while to do this, but I would just want to make sure you guys see what's going on. So now what we're going to do is we're going to expand and consider the case when the exponent r is any real number, not necessarily non-negative integers. Okay, so now I'm going to erase all this, and we're going to, but I'm going to continue with this, the same idea. Okay, so now let's consider when r is any real number. Okay, so now, so here's the thing. We can't write these as a finite polynomial anymore. Okay, but we can find a power series for f. Okay, so we're going to specifically look at the Maclaurin series for f. And so we're going to go through the process of finding the nth derivatives and then finding those and evaluating those at 0. Okay, so let's do that. Okay, so we have f of x is equal to 1 plus x to the r. And then if we take the first derivative, well, again, we're going to use the chain rule. So we're going to get r times 1 plus x. The derivative of the inside is just 1, so don't have to worry about that. And so we're going to get r minus 1. And then if we take the second derivative, we're going to do the exact same thing. So now it's going to be, well, this is just a constant, so it's just going to be the chain rule again. So now we're going to get r times r minus 1 times 1 plus x to the r minus 2. And then if we get the third derivative, similarly, we're going to do the chain rule again. So we're going to get r times r minus 1 times r minus 2 times 1 plus x to the r minus 3 power. And then if we go to the fourth derivative of x, it's going to give us r times r minus 1 times r minus 2 times r minus 3 times 1 plus x to the r minus 4 power. Okay, so we can see that if we take the nth derivative, what are we going to get? Well, we're going to get this. We're going to get f to the n of x is equal to what? it's going to be r times r minus 1 times r minus 2 times r minus 3 times all the way to what? R minus n. But not exactly r minus n. Well, look at what happened here. This is r, right? For the first derivative we have r, but then this is r minus 1. This is, for the second derivative, it's r times r minus 1, but then we have an r minus 2 here. So notice that for the derivative, for the first derivative, we have r. Second derivative, we have r times r minus 1. For the third derivative, it's r times r minus 1 times r minus 2, but notice it's r minus 3. This is r minus 4, but we're always at r minus, this is 1 less than this. So this is going to go all the way to r minus n, but then plus 1, right? And then we're going to, the last factor is just going to be r plus x to the, now it's going to be r minus n. Or, I'm sorry, no, not r minus. Oh, hold on a second. Yeah, that's right. Yeah, that's right. It's r minus n. Okay, never mind. I was right. Okay, so this is the way we set up the way we did with the Maclaurin series. Now we're going to evaluate these at 0. So I'm going to just write these over here real quick. So this is going to be f of 0, f prime of 0. Oh, bless me. Okay. And then we're going to go to f and the nth power. Okay. Okay, so now what are all these evaluated at 0? Well, if this is 0, then we just get 1. Okay? If this is 0 here, in fact, when x is 0 here, we just get r. Right? So when x is 0, we just get the last factor, right? The last factor in our products here are just 1. So what it reduces to is this, r, and then r times r minus 1, right? And then r times r minus 1 times r minus 2. And then this is going to be r times r minus 1 times r minus 2 times r minus 3. And then finally for the r1, so here, even better. Instead of doing it this way, I'll just show you over here with what I already have written down. Be easier. So if I want to do these all at 0, right? Which is where we're going anyway, right? We're trying to find the Maclaurin series. So if I evaluate all of these at 0, well, all that happens is the last factor goes to 1. And so this is what we end up with. Okay, now, here's where we have to put everything together. And so the coefficients, right? So this is, now here's where the coefficients come in, right? So for the Maclaurin series, remember, the Maclaurin series is of the form, right? So let's write this out one more time. N equals 0 to infinity. The Maclaurin series has the form of f of n 0 over n factorial times x to the n, right? So the binomial coefficient is given by that. Okay? So now, what does that equal? Well, it's just going to equal this, right? So the binomial coefficient is going to be, oops, given by r times, let me write this a little better. So it's going to be, well, basically it's just going to be this, right? So I'm just going to rewrite this. So this bottom one right here, so the binomial coefficient basically just becomes that. So instead of just writing the whole thing out. So this becomes the formula for the binomial coefficient. So it is a little bit different than what we dealt with when we were talking about just non-zero, or excuse me, non-negative integer values of r. Okay? So again, it's different than what we did before. But this becomes the coefficients of our binomial expansion. Okay, now, with this notation, we can write the binomial series for the function 1 plus x to the r power. And so, here's how we write it. So we have f of x equals 1 plus x to the r, which is equal to, the series equals n equals 0 to r. Excuse me. Okay, and so now what happens here? This again is equal to r choose n, x to the n, which now is going to equal to, oh, by the way, this is actually equal to r choose n. Okay, and that's how we're going to define r choose n for this case. Okay, so then this is the case where r represents any real number. Okay, so the other formula for r choose n, the way it was defined for only non-zero integer values of r, which again lends itself to things when we talk about probability of events and stuff. But here we want to develop this for all real values of r, and so now we're going to define r choose n as given by this formula. Okay, so I just want to make that clear going forward. So now that means that this series is equal to what? It's going to equal 1, right? Plus r x plus r times r minus 1 x squared plus what else do we want to do? Oh, 2 factorial. Oh, so let me center this better. So this will be r times r minus 1 over 2 factorial x squared. That's right. Okay. And then it continues in like fashion. There we go. But now the thing is, oh, wait, hold on a second. This is not a finite series. This is an infinite series. So this continues to go on. Because again, we're talking about all real numbers. Okay, so now that we've got the Maclaurin series for the binomial, or the binomial series rather, for this function, now let's talk about convergence. And so again, this is where the ratio test is going to come in. So when we deal with the ratio test, again, it's going to be the absolute value of a n plus 1 divided by the absolute value of a sub n. And so now this is where we have to, again, make sure we cross our I's, or cross our T's and dot our I's. And so this is going to be, I'm going to multiply by the reciprocal of this. So again, I'm going to write this out. And this is going to be the absolute value of what? Well, a sub n plus 1 is going to be what? It's going to be r times r minus 1 times r minus 2 all the way to what? It's going to be, well, now it's r plus n plus 1. So this is going to go to r minus n plus 1 to r minus n. Okay, and then of course we have the absolute value of x, and this is all going to be over the quantity n plus 1 factorial, so we've got the absolute value, and then we're going to divide that by this, which is then going to be the absolute value of r times r minus 1 times r minus 2 times all the way to r minus n plus 1 times the absolute value of x, all divided by n factorial. And then now what I'm going to do is I'm going to multiply by the reciprocal of the bottom and then simplify that. So I will come back and we will start from here.